Hey, Ante, thanks for joining us on another episode of our data-driven design series. Today we're going to be talking about carbon. It's great to have you.
It's great to be here, Cam. This is an issue near and dear to my heart.
Awesome. So why don't you do a quick introduction about yourself? You're Ante. We know you, but what do you do at GluMac?
Sure. My name is Ante Vulin, and I'm a senior sustainability strategist at GluMac. And what that means is that I get to help bring and focus GluMac's engineering prowess on some of the more sustainability-oriented questions. So that can range from building certifications like LEED or WELL, but then it also includes, how do we use less energy? How do we use less water? How do we use healthier materials in our building? And ultimately, how do we know that the buildings that we're designing are moving the needle to where it needs to get to seriously address the worst impacts of climate change? It's a really fun, challenging role, and it's probably pretty unique that GluMac offers that in-house compared to some other engineering firms.
Cool. Love it. So I know you hit on a couple of big topics, healthy materials, talking about how we can get to net zero, how we can move the needle. And I know that today's conversation, you didn't say it, and perhaps you're being a little modest, but you're an expert with regards to embodied carbon. And so that's what we're going to be talking about today. And so help me out, because I'm not a carbon expert necessarily. What is carbon?
Yeah, when we start talking about carbon, first, we are specifically usually talking about carbon, the element that makes up carbon dioxide, the molecule. Carbon dioxide is a naturally occurring substance. It's part of the life cycle of plants and humans and everything we see around outside us. So it's a substance that's everywhere. And the reason we pay so much attention to it is because it has global warming potential. It essentially starts to trap heat in the atmosphere. And that's been very important and throughout the history of Earth to create the ecosystems that support life as we know it. And now we're heading into a phase where there's more carbon dioxide in the atmosphere than there has been at any point in human history. So this is a very, on a geological timescale, unexpected situation. And so like I said, there's been carbon in the atmosphere for millions and billions of years. And what would typically happen is it would get absorbed by plants and then sequestered in the earth. That's where the fossil fuels we use come from this carbon that came out of the atmosphere. And when a tree dies, it releases some carbon dioxide, but another tree takes its place and takes it back in. So that's this carbon cycle that's existed for billions of years. And then what's been happening in the past 300 years of human history is we've started accelerating the release of a lot of that carbon stored over those long time cycles. And so that carbon is the carbon emissions we're talking about all the time. When you burn natural gas or you drive your car or you use electricity that comes from a coal plant, there's carbon being emitted into the atmosphere. And that's what's driving on a large scale, although there are many other greenhouse gases, this worsening climate change and warming that we're experiencing. And the specific part of that I get to play with a lot is embodied carbon. So embodied carbon is something that we don't talk as much about, but it's the carbon that somebody else is burning and releasing for you to get a product. So in the building environment, we define embodied carbon as all the emissions associated with producing and installing the materials and products that make up a building. But we can think of all kinds of products as having embodied carbon. There's embodied carbon it takes to grow food and bring it to your house and then dispose of it afterwards. And so the reason that matters is that if we really want to tackle these worst effects of global warming, there's a whole number of baskets of carbon that we need to try to reduce. And carbon becomes the great leveler of how we talk about all these different competing priorities for efficiency and conservation.
Got it. So I'm going to break that down one more time. So we have the atom carbon, and the reason why it's on our radar is because it has a global warming potential. There's a natural carbon cycle where carbon is sequestered, and then it's the tree dies, it releases the CO2, and then another tree comes along and absorbs it again. That cycle, just kind of hitting that home. And then there's this third item that you talked about, which is emissions, which is what a lot of us are familiar with, how much carbon we're putting into the atmosphere, whether that's burning fossil fuels or burning natural gas or what have you. And then there's this last component, and that's, I think, what we're going to be focused on today, which is this embodied carbon aspect. And that's the carbon emissions that are really invisible to us because we're not there when something is getting extracted. We're not there when it's getting transported. We don't necessarily think about that our fruits and vegetables are being refrigerated so that they're available to us out of season. So that's what we're going to be touching on today. And so that's really interesting because when we're talking about how much impact do our buildings have, what are some global numbers that we can be thinking of with regards to embodied carbon, and how does that relate to something that's a little bit more tangible to us, like carbon emissions? So what are those global numbers, and how does that relate back to carbon emissions versus embodied carbon?
So I think one thing we really think about and hear a lot about now are electric cars, that electric cars are the future. And they definitely play a huge role in getting to a net zero future. But I think globally, the emissions from automobiles is something like 6% of global CO2 emissions.
Wow.
And air travel, it might be around the order of 2% of global CO2 emissions. Well, just producing cement, which is a key ingredient in concrete, is around 5% of global emissions. And steel is now around another 5% itself. So 10% of global emissions come from these materials that are ubiquitous in the built environment, that we don't think about as having a carbon footprint, but they have a very real and major carbon footprint. And what's challenging about these materials is that they're harder to electrify. What part of that is chemistry? So the process of creating cement, just chemically, even if you had a solar powered cement plant, would still about half of that carbon dioxide would still be released into the atmosphere through the just chemical process of creating cement. So that's a really tough thing to do. We can have a renewable grid to power our buildings and our vehicles, but we don't have a renewable cement yet. And at the similar point, making steel requires really high temperatures, and it's very complicated and expensive to get electricity to do that at all scales. There are some electric furnaces that do a really good job, but if they're powered by a coal-fired grid, there's still a big emissions impact with that. So there's some big challenges with these industrial processes that make efficiency and smart design even more important than to reduce the actual carbon footprint of our buildings.
Wow, and so if we were to compare, embodied carbon impact compared to just a traditional building and its operations, like you said, if we're so focused on just the energy aspects of our building, if you had a traditional building, what would you say the embodied carbon impact is in scale compared to just the energy use of a traditional building?
So as an engineer, I have to answer your question saying it depends. And that's one of the big things we see on operational energy is it really depends on where your building is. Is it in the Pacific Northwest where it's getting hydropower? Is it in the Midwest where there's coal plants? Is it in a really wind-rich part of Texas? So the footprint of your operating building, varies, but it's a relatively simple supply chain because you just get it from usually one utility and they can kind of tell you what makes up all the source that goes into there. On the embodied carbon side, it's an interesting challenge because your supply chains are longer. There's many more steps before you get to the people who actually are doing the emitting. But fortunately, most of these people are doing things the exact same way. So it's a little bit less specific data, but we have some good confidence about the impact of, say, a cubic yard of concrete. So what does this mean for a typical building? So I want to give credit to the Carbon Leadership Forum that's done a lot of good research aggregating all the research that's been done on this. And we would typically say that a commercial building, a mid-rise to high-rise commercial building probably has an embodied carbon of between 30 and 50 kilograms of carbon dioxide per square foot. So what does that mean? Well, that's the equivalent of setting on fire 3 to 5 gallons of gasoline. So every square foot of a building has that impact of around 3 to 5 gallons of gasoline. It's about equivalent to driving about 100 miles, to put it another way. So if you started driving and you drove your car for 1 million miles, you would have a 10,000 square foot building.
Wow. That's crazy to think about. So a 1,000 square foot building is equivalent to driving 100,000 miles.
Yes.
That's wild. That's wild. So so we've already talked a lot in this data-driven design series about carbon emissions, electrification, building optimization. Now we're diving in one step further, and that's this embodied carbon aspect. And it is a really big issue because we can do a lot at the building level with regards to what types of systems we're employing, and then we can also do a lot with regards to the utility company, or at least being aware of what the utility company has going on. But with this embodied carbon issue, like obviously with the numbers that you're sharing, it's something that we need to take action on, or we at least need to be aware of, because perhaps there's some solutions that are rather simple or very natural to implement into our design. So I'm going to leave it at that. What can we do now? Can we do anything about it?
Well, the great thing is, yes, we can. I just as with energy efficiency, it's efficiency is where we start. Using less, making sure what we do use is being used to its highest value. That's one of the easiest ways to do it. And fortunately, using less material, less concrete is something that engineers, architects, contractors already want to do. And when we use embodied carbon as a lens, it kind of creates additional support for them to push further on that. So for example, when we think of the operating emissions of a building versus its embodied carbon, it probably takes between 15 and 30 years for the operating emissions of a building to even get equal to the embodied carbon of a building. And as we know from working on buildings, people spend a lot of time thinking about that energy. They want to know what the payback is. They want to know what the carbon impact is between different mechanical systems or lighting strategies. And we can take that same kind of thinking and we could say, well, if you're willing to invest $100 to save some amount of carbon through operating emissions, what can we do with that same $100 of value on your structure and enclosure of your building? And some of it is actually cheap. Cement costs money. So when we use concrete mixes that reduce cement, that can save money and save carbon. If we can find ways to efficiently use more structurally efficient systems, that saves hopefully energy, money, and embodied carbon. And so that's kind of the low-hanging fruit, is just allowing engineers to do the designs they can that they wouldn't have ordinarily thought of because they weren't being asked to. We have really good success when we go to structural engineers and say, hey, have you thought about delaying the strength requirement timeline for your concrete so that it doesn't have to be as strong as fast so that you can lower the cement content? They say, sure, we don't typically get asked to do this, but we can tell you exactly how to do it. And that can lower potentially the embodied carbon of the concrete in a building by 20%, by 30%, which is a huge relative amount in a building. That's kind of some of the easiest things, is just looking at these major materials. Steel, for example, can you source steel that's made from high recycled content? Because that's much lower carbon energy and carbon intensive than steel that starts out as raw ore. And that's something that, depending on the market location your project is in, can be very easy, or it can be more complicated if you have to source some more unique products. Then what we get into more advanced topics that are really popular right now are using wood. So in large buildings, wood is becoming now a choice for structural materials, for using CLT as decking to replace concrete in a way it really wasn't on the table 5 years ago. And as you might imagine, wood that doesn't, because it offsets that concrete, has a really much lower embodied carbon footprint. So we would see on some of our projects that are using a lot of wood that they maybe save 40% of the embodied carbon compared to a typical concrete structure.
Wow. Wow. Yeah, that's do these systems, do they cost more then? I mean, you're talking about making some really big moves with regards to reducing embodied carbon. I mean, using numbers like 40%, that's something that we should take notice of. Does that cost more money, or is this something that we should be, like I said, doing naturally, from the get-go?
So the short answer is sometimes yes, some of those big changes do cost more money. So there's questions sometimes just about competition. There aren't as many suppliers for some of these materials, or there aren't as many contractors who feel comfortable working with them, or just all of us, on the mechanical design side, you're used to being able to coordinate all your pipes and shafts and ducts through one type of structural system, and all of a sudden someone tells you you have to have it nailed down earlier in design. That's tough, but it's all things that we're getting better at. and the premium is dropping. And then that said, there's other advantages that you start to make up. One of the biggest ones we see with mass timber construction using CLT or other advanced wood products is schedule. You don't have to pour a concrete slab and wait for it to come to its full strength or wait for it to cure appropriately before moving on. You can do things like crane erect some of these structures with weeks of time savings, and those weeks of time savings create cost savings for the project, even if it's not necessarily a material cost saving. So there's a lot of ways that we can find these win-win-win scenarios when we use carbon as a lens to reevaluate business as usual. So because we don't accept business as usual because it's not sustainable from a carbon perspective, that lets us find places where we can save money, save time, and save carbon, and hopefully create more beautiful buildings. That's one of the biggest things that's driving people towards mass timber is they like the look of it, and the carbon then just really what makes it a slam dunk to an owner when they want to make a sustainable decision.
Yeah, that's a good point. The biophilic aspect of seeing the wood in the space is great. So you mentioned this win-win-win. Let's talk some easy wins where we can reduce our embodied carbon. It doesn't cost a lot of money. Like, what are some very simple things that are easy, low-hanging fruit, as you called it, items that we can hone in on and start incorporating today?
Sure. So what we see. So one major item is insulation. There's a bunch of different insulation products available. There's mineral wool bats, there's rigid board insulations, there's all the acronym foam insulations that EPS, XPS, that we're used to dealing with. And for a long time, the energy industry would just say R value. All that matters is R value because that's what's going to save energy. And now what we know more of is that, well, there's a huge embodied carbon aspect to producing insulation that we want to pay attention to. Because when you make these foam insulations, you need a blowing agent, and some foam it uses a substance with really bad global warming potential to just blow through the insulation board, get it nice and foamy, and then it's in the atmosphere. And that's really bad. And so when you talk about low-hanging fruit, when you're looking at insulation, we're not talking about 40% savings between one product and another. You're talking about 90% savings or 99.9% savings. Like that's the relative order of magnitude with insulation products, because some of the worst XPS products use such bad refrigerants that you can switch products or find a better manufacturer that will work much better. So that's example. Insulation is one thing we look at. Carpet and interior products, that's another thing where they may not present as much of a absolute impact as concrete, but in the marketplace, there's a lot of ways to just find products that are 50 to 60% better and get those big reductions. And what drives that is that those marketplaces have really responded to a call from the building industry for transparency.
Right.
So there's a couple great resources: Transparency Catalog, Building Transparency, websites that aggregate this published data and then lets designers make better choices about, hey, if I'm going to choose two kinds of gypsum wallboard, maybe I should consider which one is better from an environmental perspective. And you're able to kind of do that in a way you really were not able to do when I started working in the green building industry.
That's great. I want to circle back to concrete too, because one of the items that we hear a lot is the use of fly ash. So, do you want to tell people like what is fly ash? Let's just start there, and then maybe we'll ask a couple more questions.
Yeah, so fly ash is a industrial byproduct. That's why it's available so cheaply, is that it comes from the combustion of coal. So you salvage this material that goes through a combustion process but is not completely consumed, and it has some properties similar to cement that allow it to be used as a post-industrial recycled component of concrete. And it does, because it's recycled, it then gets some nice carbon benefits compared to regular cement. But the challenge we're facing in the US is that coal plants are closing and the supply of fly ash is decreasing. And so, which is good. We want those coal plants to close,
Right.
but we have to be more thoughtful. That's not just a magic bullet like 5 years ago, what people would have said, hey, we'll just add fly ash, now our concrete is better. We have to really see what we can do to use less cement. Slag is another post-industrial product that can play a role, but similar, has supply chain issues of just, there's not as much of it as we would want to use. So some of the other things people are looking at are some glass-based cement alternatives and additives that can be added in. And then there's also some research into and not just research, but real products that take recovered carbon dioxide and inject it directly into a concrete mix, so that you actually have carbon dioxide acting as cement, and reducing the impact of a concrete mix by 10%, which is great. It's an awesome story.
Yeah, so I just want to touch on something because everyone listening or watching should hear this, is that concrete's not the culprit here. Do I have that right? It's not concrete necessarily, because you can mix concrete using a variety of materials. The culprit is the cement. The Portland cement that's used is what creates a lot of the embodied carbon aspects of the embodied carbon associated with concrete.
Yes, exactly, 100%. And there's a lot of research going on alternative cements that could be less harmful, or processes to make the cement making process more efficient. But it just remains a huge challenge. And I think that's where, when we start to talk about people, is like, well, we can get you to a net zero building. But if you want to have a concrete building, there's going to be emissions associated with it. Yeah. So let's do what we can to reduce, and then start talking about what is your offset strategy, or how are you going to address this through the rest of your organization's operation?
Well, I have a question then, because, when you're doing your analysis, because you analyze how much embodied carbon exists in a proposed building, when you're doing your analysis, what if I was to do a building out of cross-laminated timber, CLT, like you called it before, and we were talking about shipping the lumber over from, or the timber over from, some faraway place? How does supply chain play into that calculation?
That's an excellent question. And that's one of the big challenges with the forest product supply chain, is that it's a little more complicated than some other products in the and the shipping is a great second part of that. So in the US, for cement and concrete, a lot of that is produced regionally because it's heavy, and it doesn't make sense to ship it a long distance.
Right. Yeah.
On the wood product side, it's lighter, it's higher value. So you do see it being shipped from overseas. A lot of times we see CLT manufacturers in Europe interested in American projects because they can make it in their factory there, ship it over relatively simply. What gets complicated is that a huge part of the theoretical environmental benefit of wood also depends on how the forest is managed. So if you were made all your CLT out of rainforest, precious endangered wood species, that would be terrible. You'd be disrupting these major ecosystems. But the challenge is, how do you know where this wood comes from? And I've been on a couple projects where they went to a big effort to really try to find ways to sustainably source their wood. And it's very complicated because, as much as we love our projects, they're tiny pieces in this huge global wood products industry. And so it's something that hopefully we'll get better at doing. And so how we approach that for our clients is that we take a pretty conservative approach, is that we're not assuming that your wood is coming from a sustainably sourced place. We're not assuming anything about the supply chain particularly. We're only going to say that just the basic manufacturing process of making a wood product has a lower impact than making concrete and cement. So it's a challenging. It's basically one of the hottest issues in the green building world, is how green is wood? How green can it be?
Got it. But it sounds like one of the common threads through it all is keep it simple, keep it local, the best that you can. So that's just an easy thing that teams can do. Well, really cool. So why don't we talk about some cool stuff that you've been involved with recently? Like, do you have any cool stories or success stories associated with embodied carbon? Like, where is the analysis of embodied carbon going?
Yeah, we've had some good opportunities of working with different architects at both early in design and late in design to try to understand, how low can we go? Some owners, some architects start out knowing, hey, we want to make a mass timber building because we know it's the right thing to do. And so we can go through them and say, first we give them the gold star and say, yes, we've documented that you did a great job, but here's where you can go further. That's where we start talking about things like insulation or concrete mixes. And so we've had some great opportunities where, with a mass timber office building where it's gorgeous spaces with glulam columns and CLT floors, but they still have this below grade concrete parking structure that they need. And so we were saying, okay, you got it this far. Now let's start talking about your mixed designs and how we're going to get better at that aspect. And I think on that project, we'll probably get them down definitely to that low end of embodied carbon, of kilograms carbon per square foot of 30, which is really good for a commercial building that has to have concrete. Mm-hmm. Then we've also had some good opportunities with larger concrete buildings where they've been in California locations where they have to have really good seismic performance, and they have to be able to perform in some very intense scenarios requested by the client. So we don't have as much latitude on the concrete side, but what we're able to do is do some really good early analysis on the facades of buildings and paying attention to how much aluminum is going into their curtain wall and how much glass, and these items that both are energy intensive to produce and will probably have to be replaced at least once or twice over the lifespan of a building. And so that's the other aspect, is not just looking at the building as it's first built, but how, once it gets replaced, what can you do to make sure you're not just making bad decisions over and over again?
Cool. What software do you use? I mean, we're talking about a data-driven design series here. So how are we using data in the tools that we're using and employing on projects?
So we love to start with BIM data. Like, we love to get our hands on Revit models from the architect, from the structural engineer, and that lets us really get, from a pretty early phase, some really accurate counts of quantities of things that are in the building. So that's our big first set of data. It's like how much stuff is in the building. Then our second source of data is how good or bad is that stuff that's in the building. And so that comes from two sources. We take advantage of some of those transparency resources I mentioned that aggregate the environmental product declarations, and that lets us really kind of self-assess how good is the market availability of alternatives. If we don't know, if there's only one thing available, we're not going to pay attention to trying to improve it. But if it's something where there's a lot of choices, we have a great chance to try to lock something in just through competition, not even through design, but just opening up to let the market give us the cheapest, best version. Then the other source is, when we need to do deeper analysis, we're relying on what are called like life cycle inventory databases. So we access that through a Revit tool called Tally that plugs into some databases, and that's where we can get a lot of more data about, okay, you have a frame wall, what's the impact of each component of that frame wall, and really dive into more detail. So and all of that data has become much more available in the past 10 years. I think this used to be a very niche thing that PhDs dealt with, and now it's something where just through the availability of BIM and the availability of these databases, design professionals actually finally have access to this and can use it to affect their daily work.
And it sounds like certification agencies such as the USGBC are taking notice of this as well, this availability, because they're offering points even for just simply doing that life cycle inventory that you talked about. Just performing that earns you a point in LEED version 4.1, if I'm not mistaken.
Yes, it does. And I want to give credit even back to the start of LEED version 4 in 2013, 2014.
Right.
They would give you a point just for getting these environmental product declarations for the products on your project. So that was a big driver for all this data to exist. Transparency has become a big hallmark of the green building community in the past 10 years, driven by Living Building Challenge and by LEED, that we just have so much more information, and we have it because people have been asking for it. That there's leadership that individual project teams have been doing and talking to their manufacturers. And that transparency then is something that we try to carry on when we don't just tell you that, hey, you got the 30 kilograms per square foot, saying this is what's driving it. This is where our data is really strong. This is where it's more of an assumption. And that helps people make good decisions, because we don't want people making a terrible decision just because we gave them the windshield sticker miles per gallon for their project.
Yeah, and it's also it feels like there's a shift in our industry as well, where the elite design firms for MEP as well as architects are able to deliver buildings that are more net zero ready. It sounds like that's a much more simple task for people to do, because the energy modeling softwares are there, the types of systems that people are considering are there, the familiarity from a maintenance standpoint, the familiarity of system maintenance is there. So that's almost sounding like it's the new norm. And now we're solving challenges like net zero water, and now looking at the embodied carbon aspects and seeing how low can we go with that regard.
Absolutely. I think net zero energy is no longer like a technical challenge. You know, it's a cost challenge, or it's a site challenge that you're navigating. It's all these, we know how to get a building net zero energy, but these questions about how do we make those equally big cuts in embodied carbon is still open-ended for some of those reasons I was talking about, that we're up against these very tough, energy intensive industrial processes. But we can be inspired. I think we're basically learning from all the energy pioneers into how we tackle these carbon problems.
Yeah. Well, great. Ante, this has been a fantastic conversation. Where can people go to learn more about embodied carbon? Like how can they continue this quest?
Well, I would say probably the best resource that I use on a daily basis is the Carbon Leadership Forum out of the University of Washington. They've done a really incredible job of aggregating the research and aggregating the professional work. They get a lot of input from industry, which means that the information you get there is not purely academic. It's based on real projects, and it's a great starting point for anyone who wants to understand how to reduce the embodied carbon of their project. And if you're maybe not as much of an engineering nerd, I would say the Carbon Smart Materials palette is another great way to just get some big qualitative perspectives on what drives embodied carbon in the built environment.
Great. And I'm going to do a plug for drawdown as well. If people want to kind of get that global understanding of how we're operating as an entire planet, some really breathtaking numbers are provided by that group too. So Ante, thanks again for joining us on the Data Driven Design series, and looking forward to more conversations on embodied carbon.
Thanks. Always love talking about this stuff.